Welcome to Chapter 7, Using GIS to Make a Map. When most people think about GIS, what they're really thinking about is making maps. But GIS is actually a lot more than that. This is the earliest I've yawned yet in making one of these videos. It's a running joke. I can't control my tendency to yawn as soon as I start making these things, but I don't think I've ever done it in the first slide before, so there's that. Anyway, what we're going to talk about is just using GIS to make maps, and we'll go through some of the basic stuff. You have a Esri sponsored training lab, just like you did two prior labs. This is the third one. I believe this one takes about an hour and a half maybe to do, so it'll be a little bit of time there. Additionally, you have the double vocabulary quiz from where we had, the one from last week, or prior, that we need to combine. In order to take the quiz, you have to have the Respondus lockdown browser, and if you don't have it, provided a link that will take you to the college's page. Tells you all about it, and it has a video and some stuff there that shows you how to and what to do to download it. But beyond that, this week will be a pretty straightforward week. Watch the lecture, take your quiz. Now your quiz is closed note, closed book, don't use anything else, sort of a quiz. And then do your lab and read the chapter for next week. There will not be a Zoom meeting this week, okay? We're not going to do that this week because pretty much you've got everything that you're going to need is going to be here, so it shouldn't be a problem. If you have any questions, shoot me an email. Otherwise, we're going to go on with the lecture and get you guys onto your work. So some basic terms we're going to talk about is cartography, maps, visual hierarchy, geographic scale, map scale. And cartographic, generalization. So what is cartography? A lot of times people refer to it as the art and science of map making. And it's basically how we artistically display our spatial information. And we do it in such a way that it is understandable, pleasing, and useful. Maps are how we represent geographic data. Visual hierarchy is how features are displayed to highlight prominence. And so it's about how you display things in your map so that the things that are most important stick out or jump out at you. Geographic scale is the real world size or extent of an area. And map scale is the ratio of size on the map to the size in the real world. And cartographic generalization is when we simplify items represented on a map so they're not as complex or detailed as what they are in reality. An example of this would be like if you looked at a map for an entire state and you had dots as representations of cities. Obviously the city's not a dot. The dot represents the city. You might have a line to represent a road, but the road could be really complicated with lots and lots of subtle changes of direction. The line road could be very simplified and not have near the detail of the actual road. Here we have a nice map of an airport, and you can see that if you were to go out to this airport, it's not going to actually look like this. So we have taken cartographic generalization with a lot of features here, and we've got the various kinds of scales and things like that, and we've put certain things on here to stick out, and other information is just supporting, and that is effectively what cartography is all about. For example, this is the actual airport. It's darker, it's bolder, and it comes out obvious when you look at it. When we look at maps and we talk about map design, there are certain things that we talk about as far as elements of maps that are just basic stuff. Scale bar, and the reason we put scale bars in maps is because it gives you an idea of the size of things on the map. A north arrow to help explain direction. A legend to explain any colors or symbols that are on the map. A title so we know what the map is about. We use different fonts of different sizes and different colors because of the readability, the prominence, whether or not we embolden those fonts, are just different ways of sharing information or importance. And then, of course, there's a layout, which is basically how we place all these things together. And sometimes we do that using a template, which is a pre-designed layout that you simply put data or information into. So when we talk about scale bars, this is what we're talking about. Scale bars are not super complicated. They're just a line that goes across, typically in the bottom of your map, that have various breakdowns showing distances. The idea being that you can look at the distance on the line relative to things on the map and get some idea of how far apart things are. These are north arrows. North arrows have the unenviable and very important task of pointing north, which is important because it allows you to sort of rectify your map into a real world orientation so that you get some idea of what's to the right of you, to the left of you, in front of you, or behind you. Another thing we often use is a legend. And this legend here would be really kind of busy. It shows you the symbol we use for hospitals and fairgrounds and bridges and railroads and interstates and highways and major and minor lakes, as well as all the land use that's occurring on all the land space. And so this is typical of what you might see in a more complicated map, and this just breaks it out so when you see a yellow line you can look and say, oh, that's an interstate, or a red line, say, oh, that's a highway. Or when you see a green polygon, if it's a dark green, it's deciduous forest. If it's light green, it's evergreen, and if it's somewhere in between, sort of a middle green, it's mixed. And this is how you work and use these things. We talked a little bit about font, and here are some examples of different kinds of fonts and how they may or may not be used. Obviously, some of these are not good for maps. Fourth one down the left, while it's pretty, it might make a good title. It would cause undue complications to use that to label things on the map. This is a map layout. This particular layout has 3 data frames, one for the Counterminous US, and one for Alaska, and one for Hawaii. Each map is displayed, or each data frame rather, is displayed at different scales, and so each one has its own scale bar. Each map, though, follows the same general expression in terms of the data, and that is showcased in the legend, which shows us where capital cities, rivers, interstate highways, lakes, and state boundaries are. Obviously, the title is the United States of America. There's projection information and other things over to the right. All in all, this is a basic layout that would work for this kind of information. We make different types of maps, and we make them for different reasons. The first type we're going to talk about is a reference map. Reference maps give you locational information, where things are relative to other things. The second type is a thematic map. These convey some particular theme to the reader. So think of a map that looks at something like, for example, land use. And every square inch of land is classified into one use or another. The theme being, hey, how is the land being used? And the different colors indicating that. Graduated symbols are a type of thematic map, and they typically show changes in values across space. Think of little tiny triangles representing volcanoes. The bigger the triangle, the larger the explosion last time that erupted, or maybe the frequency with which it does things, or maybe instead we look at dots for earthquakes. The bigger the dot, the higher the magnitude of earthquake. That's the kind of things that we're talking about here. Choropleth maps, they're a type of thematic map, and they typically use colors to show classes within a data set. And so when I was talking about a thematic map, a basic Choropleth map is what I'm generally referring to. And so here is an interesting map. This map shows all the counties in the U.S. and who they voted for in the Obama-Romney presidential election. And you can see that the vast majority of the counties, Mitt Romney won. But counties are not equal in population or size. And so while most of the counties voted for Romney, the counties with the most people tended to vote for Obama. Some states divide their delegates up differently. Some give it to whoever wins the most. Some divide it equally between the candidates based on percentages. Ultimately, you pick a state, say California. Less than half of the counties voted for Obama, but he carried California because those counties that he carried are those coastal counties where the larger population centers are, the bigger cities, the more people. And so even though he didn't carry as much of the state on an area basis, he did in a population basis. Lots of things, lots of information you can share with a really simple map if people take the time to think about it. One of the things you have to do if you want people to understand what you're doing is classify your data. And the reason is, to better display data, you got to group things together in classes, and how you do it matters. There's lots of techniques. Some are arbitrary, some are mathematical. What the best way to do it is driven by the data type and the desire to convey knowledge. When you classify information, what you're really doing at the fundamental level is making the information more understandable by those people looking at your map. If you're doing anything else, you're being, shall we say, disingenuous. You shouldn't make classes to try to make a point. You should make classes to make the data more understandable. If in doing so it makes your point, that's a bonus. But if you classify your data just to make your point, you're purposefully misleading people looking at your map, and that's really not ethical. Some of the techniques we use are natural breaks. Natural breaks clumps similar data together and separates data that is dissimilar. It is a unique process. It calculates the standard deviations within each group. It realigns the groups. It does the calculations again and again and again, each time changing the size of the groups, because what it's trying to do is get that magic combination where every group is as homogeneous, in other words, as similar to itself as possible, and the individual groups or classes are as heterogeneous to one another as possible. In other words, they are as different from each other as possible. And by measuring the standard deviation, or the variance, or the variability, if you will, within these individual data sets, it looks for that combination where things that are alike or most alike are lumped together and separate from things from which they differ. Equal interval is just equal interval. Standard deviation makes classes based on the number on the standard deviation of the variance of the entire data set. Normalizing data is something that we do where we'll take another bit of information and use it to standardize or normalize our values. Think of it like the example they're using here, standardizing for each state by size to get houses per square mile. So if you're just looking at vacancies in terms of houses, large states might have more vacancies, but what is the density of these vacancies? How many vacancies is it per square mile? That's what matters, because in a really large state, you need a lot of houses vacant, because otherwise you won't have enough open houses. But if you're in a state that has a relatively small area, then you need less. And so how do we control for that so that we're not just trying to decide if this state with 14 and that state with 15, which one has the most? Well, if we calculate it out as this ratio between count the size, normalizing the variable by the different sizes of states, now it makes sense. Now we know that if a value for one is at 10 and one is at 11, the one that is 11 is more. So here are some maps looking at that kind of stuff. If we look at natural breaks and we choose 4 classes, these are the classes and the way it breaks down on the map. FYI, as map designs go, this is horrible. Notice that giant gaping hole on the left side of your map. This map would have been much better served if Alaska and Hawaii were in their own data frames and increased in size and positioned along the left side of the map, and the continental U.S. made larger and the legend shifted. Looking at quantiles, quantiles just simply goes from low to high and divides the data up into equal number of classes. And so that the lowest class is the lowest fourth, the next class up is the next fourth, the next is the top, is the from 1/2 to 3/4, and the last class is the top 25%. And you can see you get a very different map than what we had prior. Equal intervals, we just have a sort of a standard number break, and we apply that same break to each one. In other words, saying that from top to bottom in the data set, we just split that range up into 4 equal parts, and it looks like this. Nothing like the other data sets. Standard deviations, again, just another way of doing it, another way of making classes, still doesn't really show much. When you compare them, you notice that they all point to one state as having that housing value being the highest, and that being Maine. But when you look at it in quantiles, you also see that Florida is really high. When you look at it in terms of natural breaks, Florida is not in the same class as Maine and some of those northeastern parts, but it does have similar tendencies. And what we can see here is that certain states, Florida, Arizona, New Mexico, those sort of places, people tend to go there in the wintertime. Where do they go there from? Places like Idaho and Montana and Michigan and Minnesota, etc. Colors are also real important in making maps. There's a couple of different color schemes, red, green, blue, and cyan, magenta, yellow, and black. RGBs are designed for computer screens. CMYK is primarily a graphic designer's format. But in general, if you're going to use a color ramp, use one. Multiple variables or classes, use multiple colors. We can have single U or multi-U color ramps. Single U color ramps tend to work good for one variable. Multi-U color ramps help you sort of pseudo-classify stuff out. We're going to look at some examples now of some of this stuff and what it looks like in various softwares. When you look at the layer properties in ArcMap, for example, and that's the software you'll use in the next GIS class, under the symbology pane tab, you can look at what you're displaying, whether it's categories of stuff or quantities of stuff, whether it's graduated colors. You can pick in the fields you want. You can normalize it. You can classify it different ways. It gives you the ranges. You can select the colors. You have an awful lot of flexibility. When it comes time to make your maps, you can control it as portrait or landscape, how big it's supposed to be, and do a lot of other little things to make your map better. When we're looking at data in GIS software, one of the things we really have to remember is that we have a data view and a layout view. Data view is the information when you're working on it. Layout view is the view of your map document, not just mapped data. Some more examples. Scale of the data, it's in the circle there. Scale bars, not the same thing. Scale bars are more about the ratio of data in the real world to data in the map. And then the scale bar allows you to figure out real distances on the map. And there's lots of options, and there's lots of properties and lots of ways that you can change that. Changing everything from simple things like the font to where and how many tick marks you see on those lines. Again, all kinds of properties there you can change. North arrow, there's more north arrows to select from than you can shake a stick at. When it comes to the legend, any data that's in your map can be added to the legend, but just because it's in the map doesn't mean it has to be in the legend. Sometimes data is just there for moral support, like a background image or something like that, and maybe you don't need that. Maybe you're only interested in the one thing. That's what you put in the legend. As far as titles, text box, they don't work quite as intuitively as what you might think, but they're not bad. You have to go into the text tab to change the text, the size and position to change the size and position. And of course, you can also select any number of fonts, sizes, styles, and colors. And when it comes to putting a title in, pretty simple thing. Gives you a box, you type in the title, it puts the title in the box in the map. As far as adding these things, you can do a lot of it right from the Insert tab. That's where you can go in and put in a title or text or dynamic text and neat lines and legends and north arrows and scale bars and all this stuff. And this will become more clear when you're in the next class and you start looking at adding these things in from the ArcMap software. It'll become second nature in relatively short time.